Hey friends, we are going to go ahead and do 1-7 notes, and I'm going to have a cold, so that's what we're doing. We are going to learn something called rational functions. Rational functions is a quotient or a fraction of two polynomials. So you'll have one on the top and another one on the bottom. So a rational function is one function on the top, one on the bottom that are both polynomials. And this g of x can't be 0 because it's on the bottom, and you can't have the bottom equal to 0. So these are examples right here. You've got a fraction of a polynomial on the top and one on the bottom. Okay, so we're going to start to learn how to know things about these graphs of the functions without having to graph them. And I am really confused. Okay, there's blanks in this box that shouldn't be here. So basically what we're going to be looking at is what's called end behavior. And we want to know, we've talked about this before, we want to know what the ends are doing without having to graph it. And we can't use just the degree and leading coefficient anymore because it's not simply a polynomial, it is a fraction of polynomials. So we're going to try to figure out what is the right end doing and what is the left end doing. And to do that, we're going to look at just those leading terms, just like we did before, but we're going to be comparing them, not looking at just one. Okay. And so you would have like our rational function is going to be, and then we're only looking at the first term here, plus whatever else is up top. And then on the bottom, we have the leading term to a different power, and so on. But we don't care about the rest. We're only looking for that top part. So we have three possible scenarios. If they have the same degree, so same power. So in the example that n is equal to d, then you're going to have what we call a horizontal asymptote. And that is going to be what the ends go towards. And it's going to be located at y equals a over b. And so a over b, you can tell, are the coefficients. And that would be like if you had 3x squared over 4x squared. Essentially, the x squareds cancel one another out. And my horizontal asymptote would be located at y equals 3/4. My second scenario is that the top degree of n is less than the bottom. And so in that case, you have a horizontal asymptote at y equals 0. So when the bottom is getting bigger faster. And then our third option is that the top has a higher degree than the bottom. That one gets tricky because what happens is we don't have a horizontal asymptote. We have a situation where the ends will go towards whatever your coefficient of the top over your coefficient of the bottom is. And then the power of the x becomes the top one minus the bottom one. So that one's a little bit tricky to think about. And you have a special case where if the degree of the top is exactly 1 more than the bottom, then you have a slant or oblique asymptote that the graph will go towards at the end. So that would be a scenario where you would have like an x to the, let's say a 2x to the 3 over a 5x to the second. That is 1 degree higher than the bottom. So you would have a slant asymptote at y equals 2/5 x. Because I keep the a and the d. Sorry, I wrote a b there. Oh, no, that's correct. That's coefficient. Sorry about that. And then my power would have been 3 minus 2, which is just to the 1 power. And keep in mind, that's just a line that slopes upward. So that's kind of the gist of what we're getting at. And we'll talk more about slant asymptotes on day 2. For now, let's just practice the horizontal asymptotes and such. So it says, determine if the following rational functions have horizontal asymptotes, slant asymptotes, or neither. If it does have a horizontal asymptote, write the equation of the asymptote. Okay. Sorry. All I care about are these first two things. And in this case, the top equals the bottom, so n equals d. So if you look back in your notes, we're going to have a horizontal asymptote at y equals the coefficient ratio, because essentially the x squareds cancel one another out. And if this is my horizontal asymptotes, my n's will approach that value. In this problem, when I look at the first, the top is less than the bottom, so my n is less than the d. We're taking a drink break since I'm sick. And in that case, we were told that the horizontal asymptote will be located at 0, and that means the ends of the graph will go towards 0. In C, the top degree is higher than the bottom because it's x squared and the bottom's only x. So our n is greater than d. That's our third scenario. And that means that there is no horizontal asymptote. Our top degree is 1 more than the bottom. And so then that does mean that you have a slant asymptote, and it would be located at, we keep our coefficients of 2 and 5, and then we take 2 minus 1, so it would be located at 2/5 x. And so that would generate a line that goes up from left to right when the time comes to look at that. So this one has a slant asymptote located here. Okay, same things here. The top degree is equal to the bottom, so I use my coefficient ratio, but I obviously also use my math skills, and I write that as a reduced fraction. So that's the location of my horizontal asymptote, and will also be what my ends of my graph go towards. Here, this essentially has x to the 0 power because there isn't one, and so this time your top degree is less than the bottom, and that generates a horizontal asymptote at y equals 0. And again, this is like having x to the 0, so in this case, again, the higher degree is in the bottom, and the bottom is going to be getting bigger faster, so the horizontal asymptote will be at 0 again. Okay, so when you know the horizontal asymptote value, you know what the ends are going towards. So we're going to try to get through these. I'm making this over bee lunch, so I'm afraid my kids are going to come screaming in here. So I'm going to start talking fast. It says write limit statements. Keep in mind that this limit statement is referring to the left end, and this limit statement as x approaches positive infinity is doing the right end. So here, the n and the d are the same. So my horizontal asymptote is at y equals 2/6. So essentially it's at 1/3. And if you have a horizontal asymptote, that's what the ends will go towards. So the limit of this function as x goes to negative infinity for the left is 1/3. And the limit of this function as x approaches positive infinity is 1/3 as well. In the middle, the top is less than the bottom degree. And so I have a horizontal asymptote at y equals 0. That means both my left and my right, I'm going to change that to G since it says G up here, will be approaching 0. Last one here, the top is greater than the bottom in power or degree because I have a 4th power on the top, and then the bottom is only a 3. So then I'm going to look at -3/1 and then to the x minus 3 power. So if you look at this, you end up with just -3x. So if you know that's a line going down, that means your left end is going to be going up and your right end is going to be going down because it's following that slant asymptote at the end. So my left end is going to be the limit as x goes to negative infinity of this function, and that's going up, versus the limit of this function as x goes to the right, which is going down. So that's one that you got to kind of think about. All right. Sorry. So here's the right end and here's the left end, and you can see that there's a horizontal asymptote located here at 2. So both the left and the right will be approaching that horizontal asymptote. And again, I'm only talking about the ends, so I don't care about what's going on in here. These ends are approaching a horizontal asymptote that is located at -1. So both the left and the right ends will be approaching that horizontal asymptote, which is at -1. So just keep in mind that if you have a horizontal asymptote, both ends will approach it. And the only time you have to think harder is if you have a slant asymptote. And then you've got to figure out whether they'll be going up or down. So that is the end of day 1. Hopefully that's good enough to get you started. Bye.